So it's 11 p.m. on a Sunday night. You need to send a quick 500 rupees to a friend. You open your traditional bank app. Let's just call it the Blue Giant. You're met with a spinning wheel, a session timeout, or the ultimate nightmare, scheduled maintenance. Now, compare that to Jupiter, Slice, or super.money. You're in with a fingerprint. The UPI ID resolves before you even finish typing, and the money is gone in a heartbeat. Why is there such a massive gap? Is the big bank just lazy? Or is there something deeper, something in the very code that's holding them back? As a backend developer who builds these kinds of systems, I'm tearing down the architecture of Indian Fintech. We are looking at the monoliths, the microservices, and the 2026 security standards that actually protect your money. Welcome to Money Meets Code. First, let's talk about the front-end illusion. Why do legacy bank apps feel so heavy? Most traditional banks use what we call web views. Instead of building a native app for your phone, they basically take their 15-year-old internet banking website and wrap it in a mobile container. It's like putting a Ferrari body kit on a 1990s Maruti 800. Every time you click a button, the app has to fetch an entire web page from a slow, distant server. Modern fintechs, they use native frameworks like Flutter or React Native. They utilize something called optimistic UI. When you hit pay, the app immediately shows you a success animation. It doesn't wait for the server to say okay before it starts the transition. This is perceived performance. In 2026, if your app doesn't feel instant, it feels broken. But speed is useless if you aren't secure. In 2026, the biggest battle isn't for your business, it's against fraud. Traditional banks still rely heavily on SMS OTPs, but SMS is vulnerable. It's prone to SIM swapping and interception. Modern fintechs have moved to hardened device binding. The app creates a unique cryptographic signature tied to your phone's specific hardware. No signature, no transaction. They also use AI-driven anomaly detection on the back end. If you've been in Pune all day and suddenly there's a high-value collect request from an unknown IP in another country, the backend kills that transaction in milliseconds before you even see the notification. They use Kafka streams to process your transaction history in real time, looking for patterns that a human or an old bank server would never catch. Now, let's go into the basement, the backend. Traditional banks usually run on monolithic architecture. Think of it as a giant ancient stone block. Everything, your balance, your fixed deposits, your KYC, it's all part of one massive code base, often written in COBOL or ancient versions of Java. If the bank wants to add a simple rewards feature, they have to risk the stability of the entire system. This is why they only update their apps once every few months. Fintechs are built on microservices. In a microservice world, the payment service is totally separate from the user profile service. As a developer, I can update the UPI module 10 times a day without ever touching the ledger. We use Spring Boot, Docker, and Kubernetes to scale. If 10 million people hit an app like super.money during an IPL match, the system just spins up more containers to handle the load automatically. A traditional bank monolith, it simply crashes. At the end of the day, a bank is just a tech company with a vault. And right now, the companies with the base code are winning. The big banks have the capital, but fintechs have the agility. The question is, can the giants modernize before the startups take over completely? If you're a developer or just someone who wants to understand the tech behind their wallet, hit that subscribe button. This is Money Meets Code. See you in the next one. Thanks for watching and keep coding.